In this video, we're going to use the addition or subtraction method, which is also known as elimination or linear combinations, to solve harder system of equations problems. So in the first video, we looked at some fairly basic problems where the questions were already lined up and they already had opposite coefficients. In this video, I'd like to look at some that are a little bit harder. For example, in this one, we talked yesterday about the importance of having our variables lined up. In other words, having our x's lined up, our y's lined up, our equal signs lined up, and our constant terms lined up. And clearly you can see not everything is lined up. So we're going to have to do some rewriting here. So let's do some rewriting. Doesn't really matter which one you want to do, but I think what I might do is I might bring this negative 7y over to the other side. So I think I'm going to add 7y here. Make that look a little nicer. And I'm going to add 7y over here. Therefore, we're going to have 3x plus 7y equals negative 2. And the other equation is going to stay the same. So 2x plus 3y is equal to negative 3. So now we've taken care of the problem of having them lined up. Now we need to get opposite coefficients. Now I want you to know it doesn't matter which coefficients you decide to make opposites. If you choose to get rid of the y's, what's a number that 7 and 3 both go into? 21 is that number. Actually, you could choose anything. As long as 7 and 3 both go into it, it doesn't matter. But 21 is the lowest number, and therefore would be the easiest to work with. So I'm going to make the top one a positive 21y. So I'm going to multiply the top by 3, and that's going to give me 9x plus 21y is equal to negative 6. And if I'm going to make that a positive 21y, then the bottom here is going to have to be a negative 21y. So I'm going to multiply that by negative 7, and then I would get negative 14x minus 21y is equal to positive 21. And now I can go ahead and add those two together. And when I do, the y's will cancel. Now, I think I would like to get rid of the x's. So I'm going to do this again, but this time I'm going to get rid of the x's. So if I try to get rid of the x's, then what I'm going to do is I'm going to think of a number that 3 and 2 both go into. So I think I'm going to go for 6. It's an easy number to work with. Which means if I want to make this a positive 6x, I'm going to have to multiply this by 2. And therefore, this equation becomes 6x plus 14y is equal to negative 4. And if the top is a positive 6x, then this is going to have to be a negative 6x. So I'm going to multiply that by negative 3. That's going to give me negative 6x minus 9y is equal to positive 9. Now when I go ahead and add these, the x's cancel, and I end up with 5y is 5. Let's divide both sides by 5, and I get y is equal to 1. Great. Now the rest is just like what we've been doing in the past, which is to take any one of these equations. So you have either one of these top equations right here, or the one that I rewrote. I think I like the bottom equation. So I think I like the 2x plus 3y is negative 3. And I'm going to put that 1 right in there. So remember, this is ESA, not once, but twice. For those of you who don't know what ESA is, it's when you write the equation, Then you substitute in, and then you do your answer. So I get 2x is equal to negative 6. Ooh. Which means x is equal to negative 3. And there we go. Now let's try another hard problem. Okay, in this challenging problem, the issue that we're dealing with as well is fractions. Now we've dealt with fractions before in the past. I would personally eliminate the fractions. And if you remember, to eliminate fractions, you think of a number that your denominators go into. So for example, in this first one here, I have a denominator of 2 and I have a denominator of 3. What's the number that 2 and 3 both go into? Well, that would be 6. So what I'm going to do is I'm going to multiply every term here by 6. As long as you do the same thing to both sides, you're good. You're mathematically equivalent. Okay, so this becomes 3x plus 2y is equal to 48. The bottom, let's talk about this one. The bottom, what's the number that 2 and 3 both go into? Well, that's also 6. So that's going to give me, let's see, 2 goes in there once, goes in there 3 times. So 9x. Let's see, 3 goes in there once, 3 goes in there twice, minus 8y is equal to negative 24. Great. So now we're back to the situation where I'm going to have to get opposite coefficients for one of the variables. Now, if I were getting rid of the x's, what's the number that 3 and 9 both go into? Well, the easiest number would be 9. And if that's already a positive 9, I would make this a negative 9. If I wanted to get rid of the y's, what's the number that 2 and 8 both go into? Well, that would be 8. So this is already a negative 8. All I would have to do is make this a positive 8. It really doesn't matter which one you want to do. I might get rid of the y's just because the signs are already opposite. So therefore, if I do that, I would only have to multiply this top equation. If this is a negative 8y, I want to make this a positive 8y. So I'm just going to multiply this by 4. So now I end up with 12x plus 8y is equal to, and the bottom equation is going to stay the same. So I'm going to go ahead and add these two together. So that would give me 21x. These two would cancel. Equals, so now I just have to do 192 minus 24, and that's going to give me 168. And I'm hoping that this comes out beautiful. Divide both sides by 21, and I'm getting x is equal to 8. Now I have to take any of the equations, and I actually have 5 equations that I could go with. I have this original right here. I have this original right here. I've got the 2 that I rewrote, and then actually I have these that I rewrote, so I have more than that. I think I'm going to go with the 3x plus 2y is equal to 48. And I'm going to put that 8 right in here. So I'm going to do 3 times 8 plus 2y is equal to, let me fix that. So 24 plus 2y is equal to 48. So 2y is equal to 24. which means y is equal to 12. And there we go. Not as bad as you thought. Let's try one more. Okay, so this is definitely more complicated. What we want to do is we want to get rid of our denominators. So I think what I'm going to do is I'm going to multiply this one by 6. And that's going to give me, let's see, it's in there twice, so it looks like 2x plus, these 6's cancel, x plus y is equal to 18. I'm not loving that. So I think I'm going to combine my like terms here and get 3x plus y is equal to 18. Great. Let's look at this bottom one here. I don't know if you remember, but in a previous unit when we had minus a binomial, I told you it was easier to distribute that negative. So I'm going to do that because I do think it's easier to get rid of that right now. I'm going to do the same thing and multiply by 6. So now this is going to give me 6, whoops, forgot to cancel my denominator there. Goes in there once, goes in there twice. So I end up with 2y plus, goes in there once, goes in there 3 times. So now I got to distribute here. So 3 times negative x gives me negative 3x. 3 times positive y gives me plus 3y is equal to 36. I think I'm going to combine my like terms and at least get it in the same order as the other one. So I think I'm going to start with negative 3x plus 5y is equal to 36. Okay. So now I'm going to rewrite it over here. So 3x plus y is 18. And the other one I'll bring up here, that's negative 3x plus 5y is 36. I actually don't have to do any multiplying here because I already have opposite coefficients. So those are going to cancel, and I end up with 6y is equal to, let's add these two together. And the beautiful thing is that 6 goes into 54 9 times. And I'm going to take one of the equations, and actually I've got 2 of the originals. I've got the ones that I rewrote. I have tons of choices here. I'm going to go with this one, 3x plus y is equal to 18. I chose that right from here, just so that you know. And I didn't have to choose that one, but I wanted to. So I'm going to put the 9 right in there. So 3x plus 9 is equal to 18. So 3x is equal to 9, which means x must be 3. So now we've taken a look at a couple of more challenging problems. Good luck on doing some more practice. Do as many as you want until you feel comfortable with this. Good luck. Don't forget to email me if you have any questions.